Greetings, everyone. This video is going to talk about understanding rational exponents and radicals. So this is a lot like the work we've been doing in class. And in fact, this is the sheet that you should already have. All right, so moving on. This video is not going to be very long. I'm just going to point out some things just to make sure you can get your work done tonight. So I will look at up here in the first row, just what I'll point out to you because I'm not going to do these. But I'll point out to you that when you're doing the cube root, that cube root of 27, that's asking you what number times itself 3 times gives you 27. Anytime you're doing roots or exponents, you're always dealing with the same number times itself over and over and over and over. So we're just trying to figure out what is that number. When I multiply it out 3 times, it gives me 27. People, it is not 9. All right, the cube root of 27 is not 9. So because you're not doing 27 divided by 3. So just take some time and think about that. What number can I multiply out 3 times in a row? And the product will be 27. Same thing with number 4. The index right here, the index of 5 is asking me the same thing. What number times itself 5 times gives me 32? And just as a hint, you know the number has to be small because you're multiplying a number out 5 times and the product is only 32. So it can't be a large number like 8 because 8 times 8 times 8 times 8 times 8 is nowhere near 32. Anyway, moving on. Down here on number 5, it says rewrite each expression using a fractional exponent. The first one is done for you. So what we've done in class is I've given you the fractional exponents and you've turned it back into something with a radical. Well, on this, move that out the way. On this, we're just doing the opposite. All right. So you can still use your in and out method. You could do the in and out. So since the 3 is in and the 4 is outside, that means 3 will be the numerator. Yeah, I know this looks ugly. And 4 will be the denominator. All right. And then your 5, the radicand, is just going to be the base. Now that is not 5 3/4. That's not 5 wholes and 3/4. That's 5 as a base and 3/4 is the exponent. Just on number 8, remember that if you don't see any exponents, you can assume that this is to the first power, and you can assume that the index out here is 2 because it is square root. No, it looks funny, but that's a 2. All right. Down here, numbers 9, 10, and 11. These are exponent rules that we've done before. A to the 4th and a to the 5th power. Your bases are the same, so all they did was add the exponents. So 4 plus 5 is 9. Here, your bases are the same, but you're not going to add them. I wonder who remembers what you're supposed to do on this. And if you're not sure, look it up. Look up your exponent rules. How do you divide when your bases are the same? This is a division problem. Same thing here. But I feel like this will come back to you. You all did pretty well on this. Now down here, let's get to the meat of it. So now I will do numbers 12 and number 15 for you. Number 12 is 25 to the 1/2 power. You're going to write that as your square root symbol. We don't like rational exponents, so let's write it as a radical. We don't like fractions in the exponent, so let's write it as a radical. And 25 will be the radicand, and the 1 goes inside, and the 2 goes outside as an index. And all this says is, what is the square root of 25? 25 to the first power is still just 25. So I really don't even have to write that 1. It's just the same thing. So you're just doing the square root of 25. What number times itself equals 25? And it's 5. All right, so you got that. You're going to do the same thing for 13 and 14. So put the 1 inside, the 4 outside. And then you figure out the 4th root of 16. What number times itself 4 times gives me 16? Let's see if it's 4, because a lot of you will think that it's 4. So 4 times 4 times 4 times 4. Does that equal 16? Absolutely not. You're thinking of this. You're thinking of 4 plus 4 plus 4 plus 4. That equals 16. But when you're doing exponents and roots, we're talking multiplication, repeated multiplication. So when you're trying to solve this, don't think addition. That is a common mistake, but we really got to get past that. We can't keep making that same mistake over and over and over, all right? So it's time for us to learn from that mistake. Let's look at number 15. What happens when you've got two different numbers and not just the one? So you're going to do the same thing. We don't like the fraction, so let's write our radical. And you're going to do 16 as the radicand, and 3 goes inside, and 4 goes outside. You have two ways to solve this. Your job is to get rid of both of these exponents. Now you can either do the fourth root of 16 first, and then take that answer and raise it to the third power. Or you can take care of the 3 first and then go back and do the fourth root. Either way, you will get the same answer. What I feel like will be the easier way here, because 16 to the third power is some large number, so I'm not going to deal with that 3 yet. Let's start with the 4. So I want to know, what is the fourth root of 16? Well, I just kind of talked about that up here on number 13. So the fourth root of 16, what number times itself 4 times gives me 16? Well, it's got to be something small. I'm multiplying something 4 times in a row. It's got to be a small number. It's 2. 2 times 2 times 2 times 2. 2 times 2 times 2 times 2. That equals 16. So the fourth root of 16 is equal to 2. Am I finished? No, I'm not. Why? Because I still got this exponent. I haven't done anything with the 3. So I'm just going to put it on the 2. Sorry about my writing, y'all, but at least you know what it is. So that says 2 to the third power. 2 times 2 times 2 is 8. So let's write that out. So that means number 15, the final solution is 8. There it is. 2 times 2 times 2. So you can do 16 and 17 the same way. 16, let me see. I would suggest you do all of these the way I did number 15, only because you're going to have smaller numbers. So write it out with your radical first, then take care of this outside exponent. Go ahead and figure out the root and then put the exponent on your answer. Do it that way. Why? Because on this one, you're going to have to do 25 to the third power. That's a large number. 8 to the fourth power, 8 times 8 times 8 times 8. That's some large number. So instead of dealing with those big numbers, take care of the root first. So do 16 and 17 just like I did 15. All right, moving on down here. These word problems. Don't let this trick you. You're doing the exact same thing. They're just giving you a context now. They're giving you a situation. But this variable, they're going to give you they're going to tell you what one of the variables is, and you just have to solve for the other. Well, how do you solve for the variable? You're going to solve for it just like we've done all up here. It's the same math. So number 18 says the equation t equals 0.25 d to the 1/2 power can be used to find the number of seconds t that it takes an object to fall the distance of d feet. That is very important. Distance of d feet. That means when they give me something about a distance, that's going to take care of that variable d. Very important. How long does it take an object to fall 100 feet? Well, there's my distance number, 100 feet. What I'm going to do here is show you how they got this answer, and then you're going to do numbers 19 and 20 on your own. But I'll show you how they got it. It's the same thing. So first thing is we have this formula, t equals 0.25 d to the 1/2 power. That 0.25, we're going to multiply that times d to the 1/2 power. All right, that is multiplication right there. Oh, all right. Sorry about that. That is multiplication right there. So you're just going to plug in 100 and do 100 to the 1/2 power gives you 10. And then 10 times 0.25 gives you 2.5. So good luck with 19 and 20. Email me for questions.